So just kicking off then, introduction. So I just want to be clear, this is like workshop, this is down in the dirt, it's not a lecture. However, I will present some stuff. You can interrupt me and ask questions, but all I'd ask is that let's please keep the questions focused on the content. I believe there will be a breakout session afterwards. If you're interested in anything I'm talking about, please come talk to me there. It'll be a separate room on Interspace, where we can talk. There is also going to be some work for you to do. I know you thought you'd just be tuning in to listen, but we're going to do some stuff. It's only available on Linux and Mac, no Windows. I'm sorry about that, but next time maybe. And also a little shout out to another project, the POAP project. Make sure you claim your ETHTurin POAP from Vorthalter on Discord. So diving in then, so I'm going to start the talk about video in Web 3.0 by talking a little bit about video in Web 2.0. So when I ever talk about sort of, the people making stuff in this space, I always talk about the creators. So what I've tried to do here is to give an idea, just to kind of paint a bit of a picture of who I mean when I talk about the creators. So I start with artists, vloggers, photographers, musicians. You, person listening with a smartphone, you are creating. Directors, celebrities, journalists, public speakers, dancers, the big star, the people in the props department, the producers, the writers, the yogis, the videographers, the actors. Me, right now, I am creating video, and we're also live streaming this as well, promoting meditators, podcasters, vodcasters, pornographers, yes, it always comes up, cinematographers, choreographers, performers, camera people, sound people, lighting people, studio people, hair and makeup people. These are all people who are creators in the world of video. So very much when I'm kind of working on the projects I'm working on, I'm thinking about these people and how we can serve them. Because what we have on the other end is the consumers. So these are the people who are consuming video. And I would broadly say that is you and everyone you know. So right now, many people who are probably kind of watching on the live stream or watching this recorded, they're consuming video. Now, I'm going to talk a little bit about what I call the middlemen, so the intermediaries between the creators and the consumers in Web 2.0, video in Web 2.0. So the main players, you'll have heard of consumer platforms like YouTube, Facebook, Netflix, Spotify, Vimeo, Twitch, TikTok, and Twitter with Periscope, and there's countless others that you could name, but those are maybe the big ones that came to mind. The infrastructure providers, so Amazon, do a lot of stuff around kind of server hosting and content processing, content distribution. You've also got CDNs like Brightcove, Akamai. Wowza is a bit more kind of a live streaming sort of content management solution. But there are already players that kind of provide infrastructure to this space. And you've got people like institutions like BBC, like RAI in Italy, CNN, Fox, Al Jazeera, you've heard of them all. And then you have like China as well, like that they're at play in this whole kind of video in Web 2.0 world. And then you've got like some of the more liberal things like Associated Press, independent creators, freelance journalists, private individuals kind of streaming. I want to talk just a little bit about funding, like how this typically gets funded in a Web 2.0 context. So I'd say the biggest player in here is advertising. So like pre-roll advertising when you load up YouTube and you have to watch some advertisement beforehand, or even like you're watching TV and it cuts to an ad break. So there's a lot of funding of all this creativity and infrastructure that is done by advertising. So effectively, people trying to sell you their product, people trying to pay money to put their message in front of your eyes, so taking your attention. And as we know, kind of specifically stuff around attention, basic attention token is creating a lot of kind of ad blocking sort of technologies. And there's also kind of, more broader non-blockchain based ad blocking stuff happening as well. Also, it's worth talking about when talking about funding, like talking about the state. So different countries, different nations funding broadcasting to happen, whether that's kind of over a traditional TV mechanism, or a lot of these kind of state-run media agencies are now starting to kind of be more digital as well. So it's kind of like you are watching Big Brother. It's not Big Brother is watching you, as you are watching what the state are telling you. Then you have private individuals, so that's kind of like corporate, high net worth people, or individuals, or even subscriptions. So people who pay money for premium content on Vimeo or on YouTube, or indeed they pay their kind of cable subscription. So maybe that like $50 a month to watch as much TV as they want. Also, you have like music related things in here too. As well, but kind of we'll talk about music maybe a little bit later on. So I'm sorry if I'm going a bit fast. I'll try and kind of moderate and make sure I don't go too fast, but I do have a lot to pack in. This is all being recorded and will be published later, and also being live streamed. So moving on to the next section. So talking a little bit about the LivePeer project. So some of you on the call will have heard of LivePeer. Some of you will have heard lots of different things about kind of what it is and who it is, but what it fundamentally kind of builds itself as is building open source video infrastructure services on Ethereum. So let's just break that down just for the sake of complete clarity. Like open source, this is like anyone can do anything they want with this software, MIT license. Video infrastructure services, so there's a whole heap of stuff that the internet needs in order to quote unquote do video. So this is all about creating these infrastructure services, and specifically when it comes to how it works on blockchain, paying for these infrastructure services as you use them using Ethereum. But we'll come on to that a little bit more later. So as Matteo talked about earlier, so it's the aim is to try and do some of this stuff that the internet needs for video, but to do it in a way which is permissionless, decentralized, open source, so that effectively everyone is empowered to be able to do some of the things that only the likes of YouTube, Facebook, Amazon are able to do today. There's also something there about how it's crypto economically incentivized. So this is where it kind of gets into the whole game theory stuff around rewarding good behavior for the network. And there's a continuous funding mechanism based around the LivePeer token, which I won't go into now, but there's some very interesting kind of ways that it is incentivizing humans to participate. A little bit of history. So there was the LivePeer project launched one of the first, I think, delegated proof of stake protocols back in 2018. So like this project's been around for some time and it's continuing to kind of develop. Currently, the primary focus of what LivePeer is working on is what they call the Transcoding Marketplace. So we'll kind of show a little bit more in detail later kind of what transcoding is all about. But this is effectively two things. One is testing these probabilistic micropayments, so new ways of paying small amounts of money using Ethereum, using blockchain. And secondly, around GPU mining. So effectively anyone who has mining equipment, so GPUs that are hashing cryptocurrencies right now, they have parts of their GPUs that aren't being used right now. LivePeer gives these owners of GPU capacity a new way to monetize their equipment. So right now, maybe they're making ETH, but this project is more about trying to help them make more money doing different things. Secondary focus of the project right now is around governance. So they have a lot of on-chain stuff based around the protocol, but this is aiming to create a kind of like community engagement and voting mechanisms so that it truly can be like a community and an open source governed system, as well as an open source kind of developed system. So I'd really encourage you, if you are interested in video in Web 3.0, to go take a look at livepeer.org. All their code is there, open source MIT at github.com/livepeer. So moving on to the next section around something called videoDAC. So videoDAC is a project that I'm participating in. It's entirely building on LivePeer software. So effectively think about like using LivePeer as the concrete foundations for the building. And then we're building like the first floor, like the next level up from the foundations, because there's something kind of powerful and strong being built as part of LivePeer. So we're kind of taking the opportunity to build on top of that. The DAC thing, like loads of people are creating alternative things to DAOs at the moment. So this I wouldn't say is a DAO because there's no real organization to it. It's more of like a decentralized autonomous community. So humans that know each other, work together, and can start participating. The funding for this project is all coming from LivePeer's inflation funding token. So there's a steady stream of revenue into the project. And as long as the token price stays non-zero, then that means funding to pay people to do things. So this is quite interesting for me. So current primary focus is on what we're calling stream to earn or pay to play. So this is effectively allowing or building tools and resources to allow people who are creating content to be paid in real time, so to monetize their content in real time, and to monetize it directly from the people who are watching. So I send you some video, you send me a small amount of money, you're happy because you got your video content, I'm happy because I got paid. So we're experimenting in kind of new ways of doing this kind of thing using blockchains, using cryptocurrencies. Secondary focus we have is around onboarding community, so raising awareness of the opportunities that exist in this new open source world of video, helping people who want to use it to actually use it. And this actually is a good segue into the first demo and kind of like workshop related things. So if anyone's on the call and has a Linux or Mac computer, then we should be able to run through this together. And if you have any questions as you go along, then please do stop me and jump in. Is everything still coming through, Matteo? Hello? Yeah.
Yeah. Sorry.
Sorry, it's just a little bit unnerving sometimes talking to a screen of text. Just nice to have some feedback. Good to know everyone's still there. So if anyone is running on like a Linux machine or in fact Mac, we can follow this. So it's quite a fresh project in videoDAC. It's something called the Simple Streaming Server. So this is kind of based off of feedback that people give us about like how complicated it is to use some of this stuff. The objective of this kind of project, of this publication, is to try and make it incredibly simple to get started using LivePeer. Something actually I should say now, there's for the workshop purposes, I published in the Discord chat a few moments before. Let me publish it again so that everyone has the link. Sorry, so I published all these instructions in a GitHub gist. See if I can find it now. Okay, bear with me 1 second. Discord app. Does anyone have the gist that I published in the Discord before this call?
In the Discord, yes, I have.
Yeah, cool. If you wouldn't mind sharing that so that people can see
In
what
the
it is.
Interspace or ETHTurin?
I can't remember exactly where I published it.
I
But
think you published it in the Interspace Discord. Do you want me to publish into your channel on ETHTurin?
Could you publish it into the Discord for this space?
Okay, perfect. I think I'm having online troubles. So
Okay, let me just make sure that's got published properly, because this is kind of the content for the workshop.
I can wait. I can give it to you on Telegram quickly. I sent it to you on Telegram.
Thank you. Okay, so I think in the bottom right-hand corner, you should be able to launch a Discord chat, and in that chat window, I've published a gist that is effectively all the notes that I'm running through. It will help with copying and pasting the content into your terminal so that you can kind of run along with the workshop. So I'll get cracking. So just back to the reminder, the objective here is to make it incredibly simple to get started using LivePeer. And I'm going to switch to a picture now just to kind of show what it is a simple streaming server actually does. So a simple streaming server simply receives content from a stream publisher. So maybe they're publishing a stream using OBS or Wirecast or Manycam or their own app or specialist hardware, or using FFmpeg or using a live bulb, which we'll talk about a little bit later. So this is the simple streaming server is like the hub. People can publish content into there and then consume content out of there. So it's in some ways analogous to like a simple content web server that publishes HTML and text, but instead it's publishing content that is designed to be live streaming. A little bit about like the architecture. It's going to open some different ports on the server, and it will receive and serve content to and from those ports. So what I'm going to do is actually just like crack on and do this and run through the workshop. So these first two steps I've already actually done. So the first one is going to download a zip of the binaries of LivePeer's latest software. So 0.5.7, I think it was published about 2 days ago, so it's pretty fresh. So the wget command will download the Linux version. If you're on a Mac, you just have to change that Linux to Darwin, and that should download the Darwin version. And then tar-xzf is gonna unzip the zip file that you've just downloaded onto your local machine, and then we can start running some commands. So we're going to start by running this command, which is running LivePeer in a broadcaster mode. So I'm going to copy it out of here and into what hopefully should be my terminal over here. So I'm going to paste this guy in, and it's going to start this service on this computer, effectively running as this streaming server, simple streaming server. And what this is doing is it's created a place where you can send video to it, this video ingest point, on this URL, RTMP, blah, 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 on the local host on port 1935. And back to the text. What we're going to use a piece of software called FFmpeg to publish a test stream into that server. So we're going to switch to a new terminal window. Oops. Whoa. Okay, this isn't going like I had expected. Bear with me 1 second. Okay, let's try this again. Okay, so this is starting now to stream content into this streaming server. You can see that a video has started to be received called Hello World, and it's going to start receiving this video and chopping it up into segments, which can then be served in a stream, in a process, in a sequence, and this effectively creates your live streaming server. So this is just a test signal that's being published into the simple streaming server. And what we can also now do is to play back the content from this simple streaming server so that we can see what it looks like. So we're going to do that by running a command ffplay, and we're going to paste this into terminal. So this is playing the content out of the simple streaming server. And what we should see is this test signal coming up on the screen. I don't know if you guys can hear the sound. The sound is just like a monotonous noise. Can someone let me know if you can hear the sound, or if it's only me that can hear that?
No, we cannot, but it's a scene. So basically, it's a.
Yeah, right. Okay, so you can't hear it, but that's fine. You can hopefully you can see the screen. So what we have working now on my local host is a very, very simple streaming server. So in this command, I'm streaming content into the simple streaming server. Here, it's receiving and it's processing the simple streaming server. And here, it's playing back the content. So is anyone out there trying to make this work and is struggling to keep up, or any feedback from the audience about trying to make this work?
I think they might be actually taking notes and following you as you go. I mean, this process is quite linear.
Yeah. Okay. So I'm hoping it should be quite simple. And all the notes for this are published in the gist. So if you don't want to do it now and you want to go back at a later time, then we can you can do that. So this bit I said I would only do if I had time, and I feel a little bit under time pressure, so I'm going to skip this out. But it's effectively ways of publishing, instead of publishing a test signal with a test card, to use a piece of software called Obs Studio, which is more like drag and drop, that allows you to add pictures and nice sounds and stuff from cameras. It's really a very, very powerful tool that allows you to do some quite interesting things in publishing live stream video. Also, you can play back that source stream using some open soft, like something like VLC player that can open network streams. I really would recommend, if you're doing that, to kind of open it up using a graphical user interface, as well as using FFmpeg and ffplay. But I'm going to skip that one because just in the interests of time. So that was the simple streaming server. Now I'm going to move on to talk about the pay-to-play streaming app template. So first off, answer the question, what is a template? So a template it's the code that is required to launch your own application for paying to play your stream directly to you. So it's not an app that you can download, although they have the project has published an app using this template onto Google Play. But this template is effectively, you configure it with a few different parameters, and it generates you all the files you need to be able to publish your own app on Android. And if someone is using that app on Android, then and they're paying to watch, then that must be paying to an address that you configure. So talking very briefly about the user experience for this. So The objective for this guy was entirely to build like the simplest user experience you could possibly have. No username, no login, no password, nothing. Like if you're an Ethereum, like if you're Ethereum savvy and you understand how Ethereum works, it should really be a very simple thing. But in terms of user experience, we've gone for the tap the icon to turn the TV on and tap it to turn it off. So like no more complicated than that, really trying to focus on as simple as it possibly can be. Switching to the slides now. So just to kind of show how the app looks. You load up the app and it loads your wallet. So this is an example we had. We launched Girly TV, where you pay in Girly ETH. And this would be like the paywall page. So if your app's wallet doesn't have any money in it, then you can't pay the 0.005 Girly ETH to watch the live stream. However, if you send some money to that address, to the app's address, then it will load the stream and will start paying every minute to an address for watching this live stream content. So that's the kind of the flow. Again, focus is on really trying to keep it very simple. We can add kind of more complexity later if we need to, but for now, that's the flow. So what I'm going to do now is I'll keep talking a little bit about this pay-to-play streaming app. So it's completely open source and published in the videoDAC Android repo on GitHub. I actually want to talk about how it's been built with Gitcoin. So some of you on the call may be familiar with Gitcoin, but this project, this app was built off the back of raising an issue in GitHub, adding a Gitcoin bounty using live peer tokens. It was picked up by a guy called Malili, who lives in Nairobi in Kenya. He's a software developer. He's also under lockdown right now, so that's fun. But he's developing software to participate in the videoDAC community and contributing it to this repository. So I think that's kind of cool. He's actually currently working on integrating Connext, which is another sort of micropayment solution on Ethereum, so that we can enable payment per second. So right now the app is just defaulting to native ETH payments, and it's payment every minute, including gas prices. So we're looking to kind of streamline that to make it a lot more kind of user friendly. So we're going to run through now workshop about how to actually generate yourself one of these apps. This will only work if you've got Android Studio installed. And something I've done in advance, just because I'm on a slow connection here, is download the code. So you can do that with git clone at that place. So I'm going to load up Android Studio. It should take a few moments to load. And if you're loading up Android Studio as well, then this could be interesting. Please hold the line while the Android Studio connects. Okay, it's possible that the resources of this computer are being overloaded right now with recording things. So let's see how this works. Yes, Android Studio is loaded. So this is the kind of the initial page. So we're going to import this Gradle project into Android Studio, the one that we've downloaded already in using git clone. So where is it? It's in the Android repository here. So I already downloaded this repo to my local machine, and there's the Android project, and I click OK. So what this will then do is load up the code for the template for the app. And if you know your way around Android Studio, this should be a very kind of simple process to work on. It's just loading up the project now. I'm sorry this is taking a little bit of time. How am I doing for time, actually, Matteo? Okay,
30
Matteo does
minutes
not.
left, something.
How many?
30 minutes.
Aha, okay. I thought I had less than that, but okay, great. 30 minutes then. Okay, so we've opened up this this project now in Android Studio, and all it needs for us to do is to configure the certain configuration parameters to allow us to launch. So these configuration parameters were used in this. So welcome to Girly TV, viewing credit balance, all this text is configured in this XML strings.xml. And let me just show you exactly where that is. So if anyone's following along, they can see. So in res values strings. So this is all this stuff. So you can change this. Instead of being Girly TV, we could call this ETHTurin live. We could set it so that it sends money to ETHTurin.eth. We're using a certain endpoint for Infura or for loading up stuff from Ethereum blockchain. That's I'll keep that the same. This is the text that it shows when it's loading the wallet. This is the text it shows when it's loading the stream. This is the text that it shows on the paywall page. So these are all pieces of configuration that would allow you to take this Girly TV example and launch an app for whatever your event might be, or if you're a creator, you can launch one of these apps and configure it so that the payments would be sent directly to you. So we configure this in strings.xml and also in this utils.kt. So this defines how much the streaming fee would be per minute in ETH. So let's change that to, this is high quality content, so let's charge a bit more. This is the address that we'll send money to. And here is the place you'll get the content from. So this is where the content would stream from. And this is exactly the kind of thing that a simple streaming server that we demonstrated just previously would be able to provide a stream into this app to allow then someone to publish the app so that people could pay to them to watch. So high level example would be, you set up an ETHTurin live stream app where people must pay using Rinkeby ETH, so it doesn't cost any money, but still you can watch how the payments get made to whoever is streaming the content and to the address that that is publishing the content. So I kind of feel like, just going back to the flow of the presentation now, I haven't been able to go run through all of that because I'm trying to keep moving to make sure I kind of fit in as much as possible. But hopefully I've shown enough now for people to be able to take the full instructions for this template app and generate it. We've actually written up full menu of how to generate your application. So I would say if anyone's interested in hacking some kind of project on Video 3.0 this weekend for ETHTurin Hackathon, I would say a good place to start would be with a simple streaming server and also with this Android app, because I'm sure there's many great ideas that these kinds of things could provoke. Okay, maybe it's a good time actually now to pause for questions. If anyone has any questions on anything that I've said, let me switch back to the main chat group. Okay, everyone's staying muted and everyone's staying camera off.
So basically, you are addressing, the use of this template relies on the streaming backend infrastructure that is published on videoDAC GitHub, and that's the app use. So it doesn't have to install. That's important to say. You don't have to mess with SSL certifications. You don't have to mess up with Nginx and
Right, right. So the intention there was to try to make it as simple as humanly possible to, one, get streaming, so get some streaming content being served somewhere. So the simple streaming server should be a really easy way. Like, I wouldn't necessarily recommend putting it on your local host, but it's probably better running on a virtual server somewhere, or on a host server that you run yourself. So dedicated infrastructure for you to stream into. And then the second part of it is this pay-to-play application template that if anyone can follow the instructions and download and install some software and do some certain things, then it empowers them to be able to launch their own pay-to-play streaming. So for me, like, I don't create so much content, but I know a lot of people who do create music, create video, create films, create podcasts. There's a lot of people creating, and right now I'd say the models for allowing those creators to monetize that creativity, there's no funding coming through. So this is really focused on trying to get some funding into the hands of the people who create the content. Like, my broad theory is, if we can do something like this, then there will be an explosion of beauty and creativity in the world of video, because everyone will be able to do it all the time who wants to, and get paid if people are watching. So this is, it's still early stages, and it's still quite experimental, and the interface is still very kind of rudimentary, but we're effectively just trying to kind of prototype these things and prove the model and show something, to show like a minimum viable concept. Okay, so perhaps I'll switch now back to the presentation and keep going on this. But I do recommend, like, if anyone wants to reach out to me on the Discord in the chat group, if you want to get any of these things working, then I am ready to talk. So I'm going to move on now onto a slightly more substantial demonstration. Like the first one, I think was quite simple. And this next demonstration, it's going to be to help you set up what I'm calling the simple streaming transcoding server. It's becoming a bit of a mouthful, but still. So the streaming server we saw earlier on was relatively basic. It just took content in and served content out. So what we're aiming to do here is to add a transcoding layer into this server, so that it effectively makes the content really, really, really accessible. So making it available in a variety of different sizes to fit different device sizes. So people on slow internet connections can watch in like lower resolution. People maybe with less powerful devices can watch in lower resolution, effectively so that more people can watch live anywhere in the world. So as long as you have an internet connection, the transcoding shrinks the content down so that it makes it a lot easier to consume and to transport. So I'm just going to switch to a little picture that shows kind of the high-level architecture of this thing. So same as before, we had with the simple streaming server receiving and serving content. Now we're adding this extra layer in down at the bottom to create an Orchestrator Transcoder. So the job of this guy is literally receive content. Maybe the content is like 1920 by 1080, so like high definition video, and shrink it down into something like 144p. That's like 256 by 144 pixels, which is a much, much easier thing for transmitting down slow internet connections into the middle of Africa or Asia or South America or middle of, like, anywhere in the world, on the moon, It's just like generally makes the content more accessible. So I'm going to use some of the same software, just configured differently to what I demonstrated earlier on. So we're going to start now by running a broadcaster using LivePeer, but where this time we're going to add a few more options. Before it was just LivePeer and broadcaster. Now we're going to add a few more things, specifically where is the address of the orchestrator? So this Orchestrator Transcoder, how do I reach that service? And what do I want it to do for me? So I want it to take whatever content I'm streaming and transcode it into this 144p, this really, really lightweight software. So I'm going to start by running this command. See if I can find where we're at now. So I'm going to run this command with the transcoding options. And again, it's turned on a streaming server that's ready to receive content and serve content. What I'm also going to do is to run this Orchestrator Transcoder. So this is another process. It's running on the same machine, on the local host, on my local machine here. And if I run this command, so you see instead of it being set up as a broadcaster, this is setting it up as an orchestrator and transcoder. And it's available on 127.0.0.1.8936, which matches the orchestrator address that was configured previously. I'm going to run this guy, and in here, what that will do is that will also set up the orchestrator transcoder. And when I now publish that same test signal with all the colors into my broadcaster, we'll see the same thing happen again. So I'm publishing it into this RTMP 127.0.0.1.1935. So that's the port for the broadcaster, and I'm calling it Hello World. So this now starts to stream content, and when we flip back to the broadcaster, which should say, yeah, it's received the video Hello World, and it's sending transcoding work over to the transcoder, and now this transcoder is processing the video segments. So this is creating not only the source stream, so I'll show you what I mean by the source stream. So this is the source. We can play that back by running this ffplay command. And wait a second for it to come up on the screen. So this is the source. This is the content that I'm streaming into the broadcaster. And that's in 640 by 360. And what we can also do is to play back the transcoded stream using a different URL. And if I play this thing, it will open another one. So here, the content is in 256 by 144, so really lightweight, really easy to consume. And here is the source signal, transcoded, not transcoded, but just playing 640 by 360. And of course, I can stream in 4K and 8K and 16K and full HD and all the different kind of crazy big formats that are coming out. But in order for anyone or to maximize the accessibility of this content, then this is why it's being transcoded down into this 144p signal. So they're not quite in sync, but that's just kind of like a playback anomaly. Everything's totally fine. And this is back to the image. Is the content is coming from the stream publisher, which is FFmpeg in this context, into the streaming server. And the source is being served out to the stream consumer, but also the simple streaming server is sending content to the orchestrator transcoder, which is sending it back so that the stream consumer is happy because they can see the content. Because if it was only being broadcast in the heavy format, perhaps they wouldn't be able to watch. So this is mainly about accessibility of content. And this is one of the main things that LivePeer project is working on right now. I talked earlier on about this, the Transcoder Marketplace. So fundamentally, to make it so that the content being streamed can be resized and formatted to make it as easily accessible to anyone in the world as possible, even if they're on a really slow internet connection. Like I've tested this thing on 2G Wi-Fi, like 2G mobile networks, and I'm just about able to get a 144p stream on a smartphone. So if you think about kind of like how that massively increases the accessibility of content, it's interesting. It's one of those things that since this kind of lockdown coronavirus stuff all started, there have been a few stories coming out about how the internet as it is, like Web 2.0, just isn't capable of handling so many different formats of content. And like the European Union saying to Netflix, you must tone down the content. You know, we don't our bandwidth can't take this. So it's just interesting seeing all that kind of stuff happening now, especially when there are tools being published to allow people to transcode more easily. And I'll talk about maybe, hopefully we'll have time in a minute to show the full demo of LivePeer. So this is like next step up live streaming platform. Like what we had before was something simple. This is still relatively simple. Sorry, I'm having to flick past these. This is still relatively simple, but it just adds this extra layer that makes the content more easy to serve and more easy to consume, which is kind of like the #1 game in town when it comes to LivePeer transcoding. So that's kind of like simple streaming server, simple streaming transcoding server, and the pay-to-play streaming app template. Really do recommend you guys to have a look at it if anyone's interested in video in Web 3.0. I'm going to switch tack slightly now to talk about another little project that I'm kind of putting together during lockdown. It's something called LiveBulb, and it's inspired by this concept of this Raspberry Pi Zero. So this tiny, tiny, tiny little computer that is effectively a full computer with RAM and storage using micro SD cards, quite a weak CPU and not much kind of power on the board, but it does have Wi-Fi. And just going to switch to the pictures. So this is the Raspberry Pi Zero. It's like smaller than a credit card. You can see there with the context with a human hand. The beautiful thing about this is they're like $10 each. Like for a full computer with 512 meg of RAM running Raspbian, so like a trimmed down version of Linux, 700 megahertz processors, micro SD storage. It's got HDMI output, so you could plug it into your TV. It's got 2 USB ports for like keyboard and mouse and power, if you need keyboard and mouse and power. And if you add like a micro SD card and a full HD camera, total cost of this is like $20, which is really small and really nice. Like, really, that's a full computer? Cool. So what I've been doing with this is putting together something called the LiveBulb. So these are the broad components of a LiveBulb. So top left is like a bulb mount, and then top right is a power charger, and then you have the camera and the Raspberry Pi. So I put it together like this, so with a light bulb shown here. This is definitely a very dirty prototype kind of model. I'm interested in knowing or developing ways of designing this to be less ugly, more user-friendly, and so on. Here's the light bulb actually in action, plugged into a light bulb socket in a wall. So that black thing you see in the middle is like, that's the camera. You've got the Raspberry Pi board before that's live streaming content. And then the light bulb is the kind of lights, camera, action cue. So it's just a kind of a fun thing that I'm developing, but it's also inspiring lots of ideas around like how else you could use a live bulb. So thought about putting them in head torches or in like motorbike front headlights. So like you turn on the car or the motorbike and turns on the light, but also turns on the live streaming camera. And maybe with a 5G connection or something, you could live stream, what's going on at the front of your car. And if you're somewhere particularly beautiful, that might be quite nice to watch. Also, the idea of putting live bulbs in like stadium lighting, so that it's lighting the football pitch, but also creating lots and lots of different interesting viewing angles for people to watch on. And yeah, I don't think there's anything really more about the live bulb in the pictures. The one thing I would say, there's an example stream that this the working live bulb is actually putting out right now. If you go to this link, live from udaiPalace.videoDAC.eth.link, this is all streaming via a simple streaming server, and actually that player is hosted in IPFS, and the address space is all using ENS. So this is like really nice for me use of technology for streaming, publishing web pages with content in them, with live streaming content in them, but publishing it on IPFS and using ENS. So you have no DNS, you have no complexity involved in like web hosting. It's super simple. So finishing off about the live bulb a little bit is, so we have this device, this rudimentary device. I'm working at the moment on defining like what an app would look like for the live bulb device. So if you wanted to configure your live bulb, like to tell it what the wallet is, it should receive pay-to-play payments into. So if you buy a live bulb, you could deploy your live bulb wherever you want, and then you could charge people money using your own live bulb pay-to-play streaming app to pay money to your live bulb, and if it's your live bulb, it's paying money to you. So these are just some interesting ideas I'm throwing around kind of using these IoT kind of devices with cameras connected to internet, using Raspberry Pi Zeros and like really small computers to live stream content into the streaming systems that I've been talking about previously. And this particular GitHub issue here, it's about building this app, like a basic starting point app. So if anyone is interested in like reviewing that in more detail and reading more about it, then do get in touch with me, because I'm interested in putting bounties on these things. Someone's come in on the call. Someone has unmuted. Hello.
Is there any questions from the viewers?
Yeah. Thank you, Chris. Pretty awesome rundown.
That Kai, is it you?
If you can. Oh yeah, my camera is coming on now. Hey. Yeah, Chris, we tried to implement your streaming backend here on the website. We're not as good, and the documentation is, you know how it is. So we could not. We're basically, if we were able to restream from our server, we would have done it. We took it last second. So, but
okay.
Lack of streamers. Question is, so next time I'm gonna ask you. But my question is, so one thing for the transcoding, you have to run then a transcoder for every resolution that would give you a different endpoint, and have to select the source you want in the player, right?
No, not so. It's not right. So some players can adapt to the different resolutions. So if you configure the player to play back one of the base URLs, then the way that M3U8 packaging works is that the base URL will tell the player, you have these 3, 4, 5, 6 different resolutions to choose from. You're the player, you know more about the bandwidth available locally, so you are better positioned to choose whether to play the really high quality one because you have high quality bandwidth, or the really low quality one. And many of these players will dynamically switch between really high resolution if it can and lower resolution if it can't. So it's definitely possible to configure a single stream, and then if your player is sophisticated enough, to be able to choose from the different options.
I would say that we might have one more quick questions and then wrap up. Of course,
I have a question, if it's possible.
Yeah.
What you're working on is totally amazing. So I thought it's impossible to do. So very cool. And my question is more in the architecture side of it. So how do you manage all of the peers and in this network to to transfer the data from the live?
Okay, so in the examples I've shown so far, there is no network, there are no peers. This is just a standalone, independent node which you can stream content into and someone else can stream content out of. So, for example, if this thing was deployed onto a virtual private server, a VPS, you could stream content into this using whatever tools you publish live stream, and you can serve content out of that. Like, there's a lot more complexity around what LivePeer is doing in terms of transcoding network and peer-to-peer transcoding, so that effectively what you can do is you can run your broadcaster node that receives content and serves content, but you can also connect this into other nodes whose IP addresses are published on Ethereum, so like published as transactions to say, here is where you find my transcoding service, here is where you pay for my transcoding service, so that an individual broadcaster can pay a permissionless transcoder to do the heavy work around transcoding content. So like the GPU intensive stuff, like the broadcasting server is just taking content in and serving content out. It's not processing anything. It's quite a lightweight service. But the transcoding, if you want to take 8K video and turn it into 144p, that's best done using GPU, dedicated hardware. And if you don't have that dedicated hardware, then LivePeer effectively provides you a marketplace of permissionless server operators who are running transcoders. The good news is all this transcoding work can go on alongside hashing of Ethereum, hashing proof of work stuff without any performance hit. So it's effectively just like layering another revenue stream onto people who own GPUs. I'm sorry, Ali, like I went off on one. I don't know if I answered your question. Did I answer your question?
Yeah.
Hey, I would say
now I have the big picture.
Okay, I would say
that's very cool.
For anyone who's interested in asking more questions and just diving into videoDAC prototypes, Chris is active and available on our Discord server under videoDAC channel, and of course he's on Telegram, and just reach out to him. He's a very kind, time-wise kind mentor. So I would say thank you, Chris.
Thank you. And if I could just say one more thing. So I'm like, there were some bits that I didn't cover on in this this workshop, but I'll be in this. I've just shared another link on the Discord chat associated with the conference room. So if you want to come and keep talking, if anyone wants to keep talking in more detail, then I'll be available on that link in the Discord.